NEC Section 551.75 mandates that equipment, enclosures, and other conductive materials within a recreational vehicle park adhere to grounding standards as outlined in NEC Article 250. NEC Section 250.32b2 stipulates the installation of a grounding electrode system, abbreviated GES, at each structure, which includes buildings or other structures that are supplied by a common service. Considering these regulations, an argument can be presented suggesting that RV pedestals should be regarded as structures. This perspective implies the necessity of an independent GES at each pedestal. Historically, earlier editions of the NEC did not explicitly address the grounding specifics for RV pedestals. However, the 2017 NEC introduced Section 551.75, which directly addresses grounding requirements for RV parks. This edition indicates a deliberate effort by the NEC committee to clarify grounding protocols for these types of installations. While the NEC does not definitively mandate driven grounding electrodes at each RV pedestal, installing them has become an increasingly common safety practice. This is particularly true in areas characterized by high soil resistivity, where a singular GES at the service entrance might not offer sufficient grounding for the entirety of the RV park. To summarize, based on NEC interpretations, the evolution of electrical codes, and current industry practices, mandating a driven grounding electrode at each RV pedestal within a park served by a shared service is justifiable. Such measures are instrumental in guaranteeing the correct grounding of all equipment, thus enhancing the safety levels for RV occupant. Considering the technical aspects, the grounding electrode system essentially provides a low impedance path for fault current to return to the source, thereby facilitating the operation of overcurrent protective devices such as circuit breakers or fuses. Without an effective grounding system, fault currents might not be high enough to trip these protective devices, potentially leading to sustained voltage on metal parts and creating shock hazards. Grounding electrodes, like ground rods, are typically made of copper or copper-clad steel and are driven into the earth to establish a direct connection to ground. The depth and number of ground rods required can depend on factors such as soil resistivity and local electrical codes. Soil resistivity measures the resistance of the soil to electrical current. High soil resistivity impedes current flow, making it more difficult to achieve a low impedance ground connection. In areas with high soil resistivity, additional ground rods or other grounding methods may be necessary to meet the code requirements. The size of the grounding electrode conductor, which connects the grounding electrode to the electrical system, is determined by NEC Table 250.66, based on the size of the service entrance conductors. It is crucial to ensure that the grounding electrode conductor is properly sized and securely connected to the grounding electrode and the main grounding busbar or neutral busbar in the electrical panel. The equipment grounding conductor, which runs with the circuit conductors to each RV pedestal, provides a path for fault current to return to the source, ensuring that metal parts of the electrical system are at ground potential. The size of the equipment grounding conductor is determined by NEC Table 250.122, based on the rating of the overcurrent protective device protecting the circuit. Furthermore, the connection between the equipment grounding conductor and the metal enclosure of the RV pedestal must be secure and properly made to ensure effective grounding. In an RV park, each RV site is essentially a potential point of electrical use, and therefore a potential point of fault. By installing a grounding electrode at each pedestal, the risk of voltage gradients and shock hazards is minimized, creating a safer environment for RV occupants. The grounding electrode at each pedestal works in conjunction with the main grounding system at the service entrance to provide a comprehensive grounding network throughout the RV park. This redundancy enhances the overall reliability and effectiveness of the grounding system. From a practical standpoint, installing ground rods at each RV pedestal involves driving the rods into the earth until they are fully buried, leaving only a few inches exposed for connection to the grounding electrode conductor. The grounding electrode conductor is then connected to the ground rod using a listed grounding clamp or connector. It is important to ensure that the connection is tight and corrosion resistant to maintain a reliable ground connection. Regular inspections and maintenance of the grounding system are essential to ensure its continued effectiveness. This includes checking the connections at the ground rod and pedestals, as well as testing the ground resistance to verify that it is within acceptable limits. Any damaged or corroded component should be replaced promptly to maintain the integrity of the grounding system. Moreover, documentation of the grounding system, including the location of ground rods, the size of grounding conductors, and the results of ground resistance testing, should be maintained for future reference and compliance purposes. This documentation can be valuable during inspections or when troubleshooting electrical problems in the RV park. In addition to ground rods, other types of grounding electrodes may be used, such as ground plates or underground metallic water pipes. However, ground rods are the most common and practical choice for RV park applications. The selection of grounding electrodes should be based on site-specific conditions and the requirements of the local electrical code. It is also important to consider the potential for stray currents in RV parks. Stray currents can occur due to various factors, such as leakage from electrical equipment or differences in ground potential between different parts of the park. These currents can create corrosion and other problems if not properly managed. By installing a grounding electrode at each pedestal, the risk of stray currents is reduced, as the grounding system provides a path for these currents to flow back to the source. Furthermore, the grounding system helps to equalize ground potential throughout the park, minimizing the potential for voltage differences that can cause stray currents. From a design perspective, the layout of the RV park should take into account the need for effective grounding. RV pedestals should be located in areas where ground rods can be easily installed and accessed for maintenance. The routing of underground wiring should also be planned to minimize the potential for damage or corrosion. The use of corrosion-resistant materials for grounding conductors and connectors is essential to ensure the long-term reliability of the grounding system. Furthermore, the grounding system should be designed to accommodate future expansion or modifications to the RV park. This may involve installing additional ground rods or upgrading the grounding conductors to handle increased electrical loads. The National Electrical Code, abbreviated NEC, provides comprehensive guidelines for the design, installation, and maintenance of electrical systems, including grounding systems. Compliance with the NEC is essential to ensure the safety and reliability of electrical installations in RV parks. Local electrical codes may also have additional requirements or restrictions regarding grounding, so it is important to consult with the local authority having jurisdiction to ensure compliance. From an enforcement perspective, electrical inspectors play a crucial role in ensuring that grounding systems in RV parks are installed and maintained in accordance with the NEC and local codes. Inspectors typically review the design and installation of the grounding system, as well as conduct inspections to verify that the grounding connections are properly made and that the ground resistance is within acceptable limits. Any deficiencies or violations identified during inspections must be corrected promptly to ensure the safety of the RV park occupant. The installation of a proper grounding system in an RV park is not only a code requirement, but also a critical safety measure. It protects against electrical shock hazards, reduces the risk of fire, and helps to ensure the reliable operation of electrical equipment. By following the guidelines of the NEC and implementing best practices for grounding, RV park owners and operators can create a safe and enjoyable environment for their guests. It is imperative to note that while this discussion provides an overview of RV park grounding requirements, it is not a substitute for professional engineering advice. Electrical engineers are qualified to design and specify grounding systems for RV parks, taking into account site-specific conditions and code requirements. They can also provide guidance on the selection of grounding electrodes, the sizing of grounding conductors, and the proper installation and maintenance of the grounding system. Moreover, electrical contractors are responsible for installing and maintaining grounding systems in accordance with the NEC and local codes. They should be licensed and experienced in electrical work and should follow all safety precautions when working on electrical systems. In conclusion, the grounding of RV parks is a complex and critical aspect of electrical safety. By understanding the NEC requirements, following industry best practices, and working with qualified professionals, RV park owners and operators can ensure the safety and reliability of their electrical systems. The ultimate goal is to provide a safe and enjoyable environment for RV occupants free from the hazards of electrical shock and fire. Furthermore, the importance of regular training for maintenance personnel on grounding systems cannot be overstated. Maintenance personnel should be trained to identify potential grounding issues, perform routine inspections, and make minor repairs. They should also be aware of the safety precautions to take when working on or near electrical equipment. Regular training helps to ensure that maintenance personnel are knowledgeable and competent in maintaining the integrity of the grounding system. From a liability standpoint, RV park owners and operators have a legal responsibility to provide a safe environment for their guests. Failure to properly ground the electrical system can result in liability for injuries or damages caused by electrical shock or fire. Adequate insurance coverage is also essential to protect against potential liability claims. Furthermore, it is important to maintain accurate records of all electrical work performed in the RV park, including grounding system inspections, repairs, and modifications. These records can be valuable in defending against liability claims. In addition to the technical aspects of grounding, it is also important to consider the human factors. RV occupants should be educated about the importance of electrical safety and the potential hazards of using damaged or improperly wired electrical equipment. RV park owners and operators should provide clear and concise information about electrical safety in their guest information packets or on their website. They should also post warning signs in areas where electrical hazards may exist. By promoting electrical safety awareness, RV park owners and operators can help to prevent accidents and injuries. Moreover, it is important to address any concerns or complaints from RV occupants regarding electrical safety promptly and professionally. This demonstrates a commitment to safety and helps to build trust with guests. In some cases, it may be necessary to consult with a qualified electrician or electrical engineer to resolve complex electrical issues. The long-term benefits of investing in a proper grounding system far outweigh the costs. A well-designed and maintained grounding system can help to prevent accidents, reduce liability, and ensure the reliable operation of electrical equipment. It also demonstrates a commitment to safety and enhances the reputation of the RV park. Furthermore, a proper grounding system can help to protect against damage from lightning strikes. Lightning can cause significant damage to electrical equipment and can even start fires. A grounding system provides a path for lightning current to flow safely to ground, minimizing the risk of damage. Lightning protection systems, which include lightning rods and grounding conductors, can be installed to provide additional protection against lightning strikes. These systems are designed to intercept lightning strikes and divert the current safely to ground. The selection and installation of lightning protection systems should be performed by qualified professionals. In addition to protecting against lightning strikes, a proper grounding system can also help to protect against power surges. Power surges can occur due to various factors, such as lightning strikes, utility switching, or equipment failures. These surges can damage sensitive electronic equipment, such as computers, televisions, and appliances. Surge protective devices, abbreviated SPD, can be installed to protect against power surges. These devices divert the surge current to ground, preventing it from reaching the protected equipment. SPD should be installed at the service entrance and at individual branch circuits to provide comprehensive surge protection. The selection and installation of SPD should be based on the voltage and current requirements of the protected equipment. Furthermore, it is important to consider the coordination of SPD with the grounding system to ensure effective surge protection. A well-designed and maintained grounding system is an essential component of a comprehensive electrical safety program for RV parks. By understanding the NEC requirements, following industry best practices, and working with qualified professionals, RV park owners and operators can create a safe and enjoyable environment for their guests. The safety and well-being of RV occupants should always be the top priority. Remember that electrical codes and standards are constantly evolving, so it is important to stay up to date with the latest requirements. Regular training and continuing education are essential for electrical professionals to maintain their knowledge and skills. By investing in electrical safety, RV park owners and operators can protect their guests, their property, and their reputation. The benefits of a safe and reliable electrical system far outweigh the costs.